Hello everyone, welcome to the anubhavtrainings.com. In this learning series video, we will talk about CDS view performance improvement and how can you analyze the performance of a CDS view which has been created in your organization. As we are seeing with the emergence of ABAP on HANA technology, more and more CDS views are being created in your company. And the next question which arises is, are my CDS views really giving me a performance gain? And if they are not, probably what can I do more to extract more out of these CDS views? So this session is inspired by a motivation which I've got from two of you colleagues who have joined and attended my S4 HANA come ABAP on HANA training. And this is why I will also present these motivational mails to at front of all of you to which inspired me to create this session actually. So the first mail which I've got for security reasons, I have removed the names of the people. So as you can see here, he has got me, he's my ABAP on HANA class student. And recently he attended an interview in the IBM with as an ABAP on HANA consultant. And they have asked me a question, how do you do performance analysis of CDS views and probably the MDP procedures? So this was one question as part of the interview which was asked to someone. And the second one was one of my another student from Fury batch. She was working maybe on a cross app, so that's okay. Now, one more request I will put you through in terms of memory consumption by CDS views. The problem is that some of the CDS views started giving memory issues in production. So like we are working on a trial balance, it will definitely be combining data of many hierarchies, multiple years as well. So now I want to analyze which joins association is causing this issue. I got some reference on the internet, so-called PlanViz, but not able to understand. It's so difficult to understand what's going on there. How can I do analysis of my my CDS view performance? So more or less same questions, and I hope this session will help you to find the right answers of these two questions. So if you think this video is helpful, please do subscribe this channel and hit the bell icon. This will motivate me more to create more content like this, and it will also help me to bring you the latest and more greatest content at front of you. Please don't forget to leave your comments below in the box if you want me to create more videos of this kind in future. So let's get started. Let's understand what's happening behind the scene before we really get into the performance part. So as you already know that a CDS view is actually created by a developer in ABAP development tools. And as we want to quickly note down our, once again, the three-tier architecture, we have presentation, application, and database layer. So for simplicity, I'm just putting here, all three layers. So let's put them up. So this is your presentation layer. Then you have your application layer. And finally, we have our database layer, which is nothing but your HANA DB in this case. So that's your HANA DB. And then on the presentation layer, now you have a Fiori UI, which only talks to an OData service. So that's where you have OData in the middle. And then we have frameworks like SARDL framework, which is responsible for preparing all the queries. Yeah. So we have then, of course, the CDS views created in the ABAP layer. So that's nothing but your CDS views out here with annotations. And then the CDS view layer is using another powerful layer in ABAP called SARDL layer to prepare the queries which needs to be sent to the database. Of course, you also have database interface in the middle, which will then publish and sends these queries to final database. And in the database, as you also know, that we do have something called database view, which gets created due to creation and activation of a CDS view. So CDS view is nothing but an object on the application layer, which you create a CDS entity. On activation creates a database view. And finally, this view, when it's executed, there's a query which gets generated behind the scene. And this query is finally processed by an engine inside HANA database. And this engine is called as SQL processor engine. So SQL processor engine finally runs this query is the agent which is responsible to hit all the database tables which you have, underlying database tables you have. So whatever tables you have used to join, aggregate all those database tables which you have, it's actually the SQL processor who actually fires the query to these database tables. Okay, so this is the guy which will actually decides in what order, in what sequence, at what rate, which table will be fetched, which join will be given more precedence, which aggregation should be done before joining the data, how the where will be executed, which are all the tables, which are all the statements which will be executed in parallel. All that is managed by SQL processor. So not necessarily the way you design your CDS, not necessarily in the same order your execution will happen. Never, really not necessary. As you can see here, there are truly many agents involved in the overall execution, and the finally SQL processor is going to take over the task to execute the queries and fetch the data from the database. So basically what SQL processor does, it creates something called a query plan. Okay, now what is a query plan? Imagine you want to go for a travel to holidays. So what you do before you to go for the travel, you make a plan that you will go from point A to point B. From there you will take a boat from point B to point C. From there you'll take a flight from point C to point D, and so on. You will plan your travel exactly the same way. There is a query plan which is created by SQL processor behind the scene in the database, which is actually going to decide the precedence level or the joins, and all these things will be decided by the SQL processor. So the performance of a CDS view, it actually depends on two factors in general. The first is the dependency tree, or basically the design time dependency. Design time dependency means what tables have you used while creating your CDS views, in what order they've used. Is there one table used in multiple CDS views, and then those multiple CDS views are again joined together, and then that's producing more or less a redundant data, and then that's joined with another table which is the same table used in the previous CDS view. So basically there's a very complex design time structure, how you join and combine together all your tables and your CDS views. So that's a design time dependency. So this is very important also at times, because it will help you to find the tables involved. So as you all learned in my ABAP on HANA come S4 HANA training, that we build view on view. Typically we start with an interface view, then we create composite views of again type of interface, then we create consumption views. So there are a lot of dependencies between these views, and also the finally to the underlying database tables. There is a lot of complexity involved there in terms of these database tables and the views, and at times knowingly you have used the same table in multiple views, and that's probably causing you this bad impact on the system, on overall performance. So that's one important factor you need to ask yourself: am I using the same table multiple times? Is it really necessary to do that? And how do you evaluate this design time dependency? This is something which I've explained already in my past video. If you have not seen that video, please hit the I button out there above on this video. You will find that video there. But however, I'll just quickly also show you. So I have already a CDS view here, which I've created for my dashboard report in S4 HANA system. And now what I'll do is I'll just go to this CDS navigator in my ABAP development tools, and I quickly click on this dependency analyzer. So that's basically going to give you a static dependency. Static dependency means what are all the different tables involved, what are all the different views involved, how they are dependent on each other. So you can see here there's a table function, CDS table function with SQL script. There is a EDIDS table used, there's EDIDC table. So there are multiple tables used, and there's another CDS view. That view has another view, and you can see here there this dependency. More or less, if you want to see it in more intuitive way, you can also go to dependency graph here, and now it shows you kind of a static dependency. So this is also a very good idea to begin with the analysis of static dependencies, how overall your view is being created. So as I can see here, this table is used twice. Now I may be asking myself to a question that, do I really need this table twice to be used? So this is the kind of questions which you can then ask. Of course, You know your data model better, you know your database tables better, you know the structure better. Of course, I will not be able to help you exactly with what you should do with your data model, but this dependency graph or tree will actually help you to find out static dependencies and maybe some kind of redundancies between which table is used twice or thrice. Is there any way to simplify that? So that's one thing which you can do. That's a static dependency. But as I mentioned, not really everything will give you as per the plan, the good results, because when it's actually processed by the SQL processor, it's not going to make the query plan as per the design time dependency, because it will check if there is something it can join automatically, if there's something it can restrict the data transfer, unnecessary data loading into the buffers, it will try to avoid. So it will make a query plan, and according to that query plan, system is going to execute. That is also the reason at times when you run a CDS view for the first time, you get maybe, let's say, X amount of time it took, and maybe next time when you run, it doesn't take that much X, it takes X minus delta X. So that delta is actually the time which it takes to prepare the first time query plan, because next time if you not changing your view, the plan is already buffered out there. The query plan is already buffered, and system doesn't really need to recreate this plan, just loads this plan and runs the query immediately. So you will probably see some performance improvement on the next execution, immediate next execution, if you're not changing the code. But yet still, you definitely would like to improve the performance. So then comes to, of course, the runtime dependency or runtime dependency and execution performance of all the dependent tables. Yeah. So that's what we will be doing. Okay. Then let's go back and see how can we calculate this runtime dependency really. So that's going to be interesting. So of course, for this, the preferred tool as in ABAP side is ST05. Again, we will be using, I'm sure all of you familiar with this, or if not, don't worry. It's called SQL performance trace. It's there since almost many years in ABAP system. So we will be using the same tool now to do the performance analysis. So what I'll do is I'll switch to my ABAP system and type the code ST05. And now here I will quickly activate. So this is something which you probably don't want to do it in your production system, because it's very costly. So sometimes you may not even have rights to activate the trace in production. So maybe just do it in controlled way to your basis guy, sit with them, activate the trace, quickly execute your CDS, come back and stop the trace, because this costs a system overhead. So be careful with this. So maybe I'll just activate, since I do have rights in the system, and you see it's been activated for my user. So now I will go back, and with my user I execute this CDS view which we created already. Just run that. It runs and gives me some results. It's fine. I'm just going to come back and say deactivate. So what happened technically, it went ahead, it created a query, it went to DB view, it queried the DB view, it submitted a query to SQL processor. SQL processor created a query plan and executed the CDS. And as a result of that, the query plan is what I want to now see what it has created. So let's go back. So I will just go to display me a trace quickly, and I will just give my object name here. So to filter, because if you just say execute, you'll see so many entries out there, but my scope is only this particular CDS artifact. So I will go back and copy this name and just put it here, and let's execute. And there you go. So you can see the total time, summation of the time taken to execute this guy out here is 309906. So remember, this number is quite important, because that's why we will be next time comparing it with. So I'm going to probably note down this number in a notepad file here for you. So the total duration which it took was this much. Yeah, I'm going to save that up. So now let's also analyze the runtime dependencies, how the query plan was prepared. So I just select this, choose edit, display execution plan. So that's your query plan I want to see, and just go inside. And now you see here the query plan. Now I'll say, please explain me the plan in graphical way so that I can understand it better. So this is the runtime plan, guys, when we executed the CD, and it starts a WebDynpro application, and that's where you can now see query plan. And I'll say, please explain me. So this was the exact query which was processed within HANA DB. Okay. So in HANA, when the view was executed, this was the plan. Now say, explain me the plan. And wow, there you go. You see here, it shows me complete execution plan, which was taken in HANA to run these. So there was two tables, this exact column tables and how much rows these tables are producing. You see these rows and their aggregations, which are performed automatically. So this is the runtime execution of your CDS view. So how the system is joining the tables, how much the number of records it's fetching, then how it's overall aggregating the results, how it's limiting the number of results, and finally producing your final results. So each of this is step in the execution is actually being depicted here with the total time taken by each of this and the number of rows which have been sent. So of course, again, it's a subject matter of your own data tables and data model, the way you use them. You can also export this and just try to take a printout and maybe just analyze it sitting with your developers in do a team review together. So this is something which you can definitely do it. So overall, this is the way you define or you calculate. Again, I'll show you. Just click on this, it'll launch the query plan. So this is where you can find out the query plan, the overall execution time, how much time it took, and what are all the things it has processed. Yeah, but what about if I want to take some generic examples or some generic rules which I must have to follow in order to get better performance? So SAP has not just given you the CDS view concept, but they've also released some strict guidelines in terms of performance. So basically, in terms of performance, when you want to achieve a good performance, SAP recommends you to use certain annotations as part of your CDS view. And if you use these annotations, you can achieve a good service quality from CDS by keeping in mind that how much resources your HANA should or how much importance HANA should give to your view. All these things are actually considered while execution. So that is the time when query plan will be prepared faster or will not be prepared faster according to those rules, basically. So that's something we'll see it in the next session. So stay tuned on Anubhav Learning Series. Feel free to write down your comments. If you like this video, don't miss out to hit the like button. And do share this with your colleagues so that they can also understand the overall perspective in terms of CDS performance. Do let me know your feedback and comments, and don't forget to subscribe my trainings on anubhavtrainings.com always. So this is the central place where you can find all the trainings related to S4 HANA, ABAP on HANA, code conversion, Fiori security, administration, S4 cloud, native HANA development, ABAP on cloud, RESTful ABAP programming model, lot of different variety of courses we are offering out here for your convenience, all at one single place with the same strategy of zero copy paste. So these videos on YouTube will help you more when you learn things from scratch. Remember, your foundation is quite important for me. When you attend these trainings, I will straight away focus right on your foundation. With that, signing out, see you in the next session for runtime performance analysis and those annotations to improve your performance. Thank you so much and see you.